Hello and welcome to Utkarsh Minds Python for Data Science and Statistics. Today we will see how to implement the paired test or hypothesis testing on paired binary data. Since we will need Python, I am launching my Colab notebook and clicking on new notebook. So once the notebook is open, we can give the name paired binary and click on connect. Then I will upload a data set, or this data can be some random data also. So for this exercise I will just use some random data. The paired binary test is for understanding whether a particular event has any effect or not. We have been given a data set. For that I will first import libraries pandas, numpy and matplotlib. Then I will collect data. So this is opinion of people about before an event. So this will be a numpy array and it will only be yes or no. So yes will be 1 and no will be 0. So I am just writing 0 1 1 1 0 0 0 1 1 1. So I am creating some random dummy data for analysis, and same I have to do for after. Only I will change certain ones to 0 and some zeros to 1. So this is before the event and after is after the event. The same people were asked whether they like let us say some particular film or not, and then after some event or maybe a trailer of that film was shown, and then they were asked, now do you like this film or not, and then again their opinion was recorded. So you can think of this as before and after comparison. Now that we have our data ready, I will create it in the form of a data frame. So this is a data frame. For that I will use the function pandas data frame, and then here I will write before and after and then again take their opinion, and then we create that data frame, and then we can have a cross table which is from pandas cross tab function. First we will have the column before and we will compare it with the column after, and here I am displaying the cross table to show you the distribution of data. So before the opinion was 0 and after also the opinion was 0, that is 4. However, there are people who have said before 0 and after 1, and similarly before 1 but after 0. So there is a change in opinion. Now using the function from stats models dot stats dot contingency tables import McNamara. Now this McNamara test we will be implementing. It is simple to implement. Just McNamara cross table, and do we want to use the exact test? Now exact means it is a time consuming test, and do we want some correction. So yeah, usually the choice is that if we are using the exact test, then we can decide that the correction should be false. So if exact is true, there is no need to use a correction, so we will keep it as false, and then we will launch the test. It is cross tab. So the test has been completed. We have got an object of bunch, and now from this object we have to retrieve our data. So instead of this, I can just print the results, and I am getting p value as 1. Since the p value is 1, the hypothesis cannot be rejected. The hypothesis means the null hypothesis cannot be rejected, and the null hypothesis says that there is no difference before and after, no difference in the opinion before and after, which means that the event had no effect on the opinion. Now we can also calculate the effect size for this test. The effect size is known as Cohen H. Since p value is greater than 0.5, we don't have to calculate the effect size because there is no effect, but still for theoretical purposes, let us calculate the effect size. The effect size requires A and B. A is when before is 0 and after is 1. So before 0 and after is 1. And B is when before equal to 1 and after equal to 0. So when before is 1 and after is 0, we get 4, and when before is 0 and after is 1, we get 3. With A and B, we calculate the H statistic as follows: A minus B the whole square, and that we will divide with A plus B, and that we will print here as Cohen H. So Cohen H we are getting as 0.14. There are several thumb rules how to interpret this. So if H is less than 0.2, then we say that the effect size is small. Else if H is less than 0.5, we say that the effect size is medium, and if the H is less than 0.8, the effect size is large, and anything greater than 0.8, we will say the effect size is very large. So this is how we interpret our Cohen H. Finally, we sum everything up and put it in a report. So here we will say that there is no difference in the opinion before and after, and so the event did not have any effect. In brackets we will say an exact McNamara test was performed and p value was greater than 0.05. Effect size of Cohen H is equal to small, in brackets H is equal to 0.14. This also we can specify, but effect size is not needed when p value is very large. So that was it about implementing paired test for binary data. It is a very useful test. You can practice on other data sets and get your reports. Thank you for watching and see you in the next video.